I wanted to present a sort of special little mini video here on converting radians to degrees. This doesn't happen a lot, but it does happen enough that it's convenient to be familiar with it. Now, there are really two kinds of problems when you're converting radians to degrees. The first we'll consider, and then the second we'll just kind of throw them in here at the tail end. The first is where we do know we have this. We do know that there are some special radian measures with which we are familiar. Pi over 6, pi over 4, pi over 3, and pi over 2. We do know, remember, 6 and 3 are reversed. Pi over 6 is 30 degrees, pi over 3 is 60 degrees. Remember, they're reversed. This is the 45-degree angle, and this is the 90-degree angle. And I suppose, as a last resort, we do know that pi is 180 degrees, if we need that. And so, very often you'll be asked to get some multiple of one of these. Multiple of pi over 6, or a multiple of pi over 3, multiple of pi over 4, and asked to convert that to degrees. It's straightforward if you sort of keep your wits about you. You might want to have a calculator handy because sometimes the arithmetic gets a little challenging, but the trigonometry should not be challenging. Because all we do is this. We notice this is 16 times pi over 3. Well, we know what pi over 3 is. We know pi over 3 in radians translates to 60 degrees. And so 16 times pi over 3, this converts to 16 times 60 degrees. And then we go to the calculator. After that, it's just straightforward, 16 times 60. And that says 960 is what I have. So this is 960 degrees. And that's true for any multiple of one of these special angles. If I want to have 15 pi over 4, well, you pair this piece, that much is pi over 4. So we know that much is 45 degrees. 15 times that corresponds to 15 times that. And then 15 times 45 is straightforward. 15 times 45 is whatever it is. It's 675 degrees. Remember, when your final answer is degrees, make sure you put the degree symbol. And that works for any multiple of one of these. So if I wanted to have 17 pi over 2, I know this much because that pi over 2 is 90. So this corresponds to 17 times 90 degrees. And so that corresponds to 90 times 17, which is 1,530 degrees. So this works for any multiple of any one of these. It doesn't have to be big. It doesn't have to be small. It could be a small value. We could have 13 pi over 6. Well, that means that is 13 times pi over 6 is 30 degrees. I know I can do 3 times 13 is 309 or 39. So this is 390 degrees, and that's all there is to it. So if it's a explicit multiple of one of these, that's the process. It's very straightforward. Now, suppose we have something like, let's go 13 pi over, let's say 13 pi over 9. Well, 9 is not one of the special angles. Pi over 9 is not one of the special angles. But we can break 9 into two pieces. We can say this is equal to 13 pi. We can break these into one of these, factor 9, so that it contains one of these factors. Right? We can use 3 times 3. And now we know what that is. That much is 60. So that corresponds to, doesn't equal, it corresponds to 13 over 3 times, I know pi over 3 is 60 degrees. And go to the calculator. This is 13 times, remember, top times top, bottom times bottom. I can just type this in the calculator. 13 divide by 3 times 60. I got 260 degrees. All right. That's true of any factor that multiplies out to one of these values. So suppose we have, I'm going to pick a number out of the blue sky. Suppose we have 25 pi over, let's say, I don't know, let's say 12. Now you have a wide choice. You can choose either 6 times, so you can choose all sorts of things here. We can choose whatever we like. Factor 12, so it contains one of these. It doesn't matter which one you pick. They're all going to give you the same result. So you could say, if you want to, you can say this is 25 pi, 2 times 6. That much is 30. So this doesn't equal. It corresponds to 25 over 2 times, what is pi over 6? Pi over 6 is 30 degrees. And then that's equal to whatever that's equal to. 25, let's clear that. 25 divided by 2, and then take that times 30. Try that again, times 30. 25 divided by 2, and then take that times 30. And I got 375 degrees. All right? Now, suppose you didn't choose 2 times 6. Suppose you chose 25 pi over 12. Suppose you chose that to be 25 pi over 3 times 4, and you hook together the pi and the pi over 4. Well, we know that much is 45. This is 25 over 3 times pi over 4 is 45 degrees. And so now let's go to the calculator. That's 25 times 45 divided by 3, and that's once again 375 degrees. It doesn't matter, and it doesn't matter if you group the 4 over here and the 3 over here. The numbers would be different here, but the final result would be the same. So if the bottom number is the bottom number is a multiple of one of these, then just write these factors out and pick the one you want to use to translate. Now, there is one scenario which is a little problematic, and this is the one I want to tack on the tail end here. What if the denominator is not one of these, or not a multiple of one of these? What if we had, something like 20 pi over 7? Yeah, you can factor 20, but we don't care about that. We need to factor the denominator. It doesn't work. Well, now you can always, at worst case scenario, you can always rely on this. That's your last stand saloon here. We know that this much corresponds to 180. So 20 times pi over 7 corresponds to 20 over 7 times that much is 180. So at the very, very least, you can always translate pi as equal to 1, or pi corresponds to 180. And if you don't know that pi radians corresponds to 180 degrees, it's time to just find a different major, because that's going to be absolutely fundamental. So the rest of this is straightforward. I got 20, this is 20 divided by 7, and then that times 180, and that's whatever that is. That's 512.285 or something like that. 514.285 degrees. And suppose we might want to round that to the nearest tenth. If we round that to the nearest tenth, that would be 0.3 degrees. All right, so converting from radians to degrees, all you need to do is know the basic angles that you should be knowing anyway. Those, once again, are going to be the devices that get you over any hurdles you need to have. Now, going the other direction is much more straightforward. Going the other direction, from degrees to radians, if I want 425 degrees, convert that to radians, the simplest way is to set up the proportion. 180 is to 425, as pi is to don't know yet, cross multiply, set them equal, and go. So converting from degrees to radians, just set up the proportion. That's the simplest thing. Convert from radians to degrees, see if you can find a multiple. If not, you always have the 180, and that'll work out. So in this case, well, I have no idea what that is. It doesn't matter. This is just a stupid little example. This is equal to 425 times pi. And so x is divide both sides by 180. 425 pi over 180. And that's equal to whatever it's equal to. We're going to have to round this probably to, let's say we're going to round this to a couple decimals. Well, actually, we could just leave it this way. That actually is in radians now. There, that's in radians. You can use that number, exact. If you want a decimal approximation, 425 times pi, divide by 180. In radians, that's 7.417 if you want it. But there, that's that you have converted 425 to radians. There it is. No problem. And if you want to reduce the fraction, that's great. So from degrees to radians is straightforward. Set up the proportion. But from radians to degrees, find it as a multiple of one of these special angles, and then multiply it out with your calculator.